Yeah, thanks everyone for joining the session. So this is a thought boot camp, and today I'm going to discuss about trace route. Okay, trace route. So before going to discuss about trace route, just let's discuss about ping. Just theoretically. Okay. So if I want to connect any website, right? Something like a website, ping www.google.com. Okay, if I want to ping google.com, it means if I want to search something in Google, I should have a reachability. How you will check the reachability? By using ping command. Okay, so ping will check whether you are able to reach it or not. See, I am getting a ping, right? So this is a domain name. Okay, so each domain name will have IP address. Okay, so ping will works at layer 3. Ping is a layer 3 thing, and it will work as layer 3, and it will check the layer 3 reachability. See here, once I initiate a ping Google, right? Google server is located somewhere else. Where it is located? Somewhere else. Okay, so maybe in Texas, maybe in UK, somewhere else in data center in this world. Okay, now if you see, right, if I'm pinging Google, so you are getting a replay from Google server. This is the Google server IP. Whatever you see, right, 142.250.195.100. This is a Google server IP. So if you want to know, so do Control C and check it in internet. Okay, check it like this. Who owns this IP? Okay, who owns this IP? Google LLC. Yes or no? Right. It is showing it, right. So it's a Google IP and it's a public IP. You are getting it. So you are getting a response from Google server. Now I'm sitting at Hyderabad Kukatpalli branch. From here to Google server is located somewhere else. So what is the connection between my computer to the Google server? The latency. So latency is 16 milliseconds. Oh my God, 16 milliseconds is very, very less. It means very good connection. I think some have you played games like PUBG? Anyone? If you see latency, right? MS. If you see 20 ms, 30 ms, you will play without any lag. Like with server you have a good connection. You can access the website or server very quickly, right? So the 50 ms, up to 30 ms, 40 ms is very good connection. If it is increasing more than 50, also is a good connection. But if it is hit to 100 milliseconds, so thousand milliseconds equal to 1 second, right? So to reach Google server from Hyderabad to somewhere else it is located, right? So to reach Google server, how much time it is taking? 16 milliseconds just. So I'm sending how many packets? Randomly I sent 4 packets from my computer to Google server. I received response from server for 4 packets, and there is no loss here, right? So ping will check the layer 3 reachability and will check the loss. Suppose if I send 4 packets, if I received 4 packets, there is no loss. It means it's a very good connection. If there is any loss, right? So something is happening between from my computer to the Google server. You need to troubleshoot it. So it will check the packet loss, and it will check how many I sent. See, sent 4 and received 4. So since it is a Windows machine, by default it will send a 4 ICMP echo request packets. Now see what is the time it has taken. On an average is 16 milliseconds. Minimum is 15 milliseconds. Maximum is 20 milliseconds. Average it is 16 milliseconds. It means you have a very good connection with your Google server, and the latency is 60 milliseconds. There is no packet loss. By using this ping command, what it is checking? It is checking layer 3 reachability and connection. What is the latency? And what is the packet loss? So packet loss, latency, right? You can check packet loss and latency and reachability. You mean reachability. These three things you will check. So this is ping. So everyone knows the packet level also. People who don't know packet level, right? For May 8th batch, I'll tell you after 2 days. Okay, after submitting class. Okay, now. So far we learn about ping. Now, what about trace route? Can we do trace route? You know, from my computer to Google server. I told you, right? There are every 30 kilometers there are routers. During demo class, I told you, right? Every 30 kilometers, 30 to 40 kilometers, they install a router till the data center, right? So 30 kilometers. So how many routers are there? From my computer to, I have a Wi-Fi connection, right? My first router is my Wi-Fi router, right? Yes or no? My computer, I'm taking an internet connection from my Wi-Fi router. My first router is Wi-Fi router, and second router is whatever the ISP I have taken, right? They have the, every 30 kilometers they have the router. Still that, till the data center, Google data center, somewhere it is located. How many routers are there? To check the path, to check the path, how you come to know? So see now. So now, if you see, right, forget about this thing, real time thing here. I'm going to teach you here. If you see, right, this is a, this is what, this is a topology. This is OSPF topology. So you can just understand it's a OSPF area 0, area 1, whatever it is. I'm going on R1 router. So R1 router, I have a route in my routing table 4.4.4. So I am trying to ping from R1 to R4. It will be ping. See, I'm trying to ping 4.4.4. It is pinging 5 packets. It is sent. It is received. You can see round trip time, latency, and everything, right? So now, if I do trace route, it will tell you what is the path. Generally, you're looking here, right? Generally, what you are doing, you're looking the topology. You know the trace, right? You know the path. If you send a packet from R1, right, it will go to R2, then R3, then R4. Yes or no? So here the R2 next IP address is 12.2. Here it is, what is the IP address? 192.168. Here 23.3. Generally, the IP address which is assigned on this interface is 23.3. Okay. Now here it is 192.168.34. Okay. Now to reach packet, right? Some packet I'm sending here. Packet. I'm sending packet from R1 to R4. Now you tell me how many routers in between. First router, first hop, what it is? 192.168.12.2. Yes or no? This is the first next hop, right? Yes or no? Right? And now second next hop is R3 router. What is that? 192.168.23.3. And the third one is 192.168.34.4. So you're looking at the topology and you're understanding this is the next hops to reach the packet from here to here. These many three routers are there. How many routers are there between R1 to R1 to 4.4.4? There are three routers, R2, R3, R4. And you're looking at the topology and you draw this. How you come to know? Practically? Practically, you can see this is a command, traceroute command. What it will do? It will also check the layer 3 reachability, whether the IP address is reaching it or not. It will also check the latency. And the wonderful feature about traceroute is it will check the path. How many routers are there in between? See now, traceroute 4.4.4. So same thing it is showing here, right? Yes or no? Compare this here and here, here and here, right? First hop. What is the first hop? It is R2, 12.2. What is the second hop? It is 23.3. Yes or no? 23.3. What is the third one? It is 34.4. Right? So what it is saying? It is displaying what is the next router. This is the next router interface IP. After that, this is the next router interface IP. After that, this is a one. So to reach 4.4.4, how many routers we have? Three routers. Okay. So it is telling latency as well, right? 28 milliseconds, 104 milliseconds. It is give you latency and layer 3 reachability as well as it will trace the path. Okay. Now my question is, once you initiate a trace route, once you initiate a trace route, how exactly it is displaying this 12.2? We are humans, we are seeing the topology, we are understanding it. But this is a router. This router is a machine. It's an electronic machine. It doesn't know this G1/0 is connected to which device. Yes or no? Right? So here we are the humans, we are seeing the topology and we are understanding it. But R1 doesn't know am I connected to R2 or R3 or any computer or anything. It doesn't know. Some cable is connected to me at G1/0. That's what it understands. Now, after initiating a trace route, how exactly it is displaying? this next ops. Shall we learn practically? Shall we see? Once you initiated trace route, what exactly it will happen? Can we learn? Are you ready, guys? We would like to know.
Yes, sir. Yes, sir.
Very important. They
Yes,
will
sir.
ask
Yes, sir.
you. They will ask you in interviews, especially in product-based companies. If you want to get a job in Facebook, Meta, or Google, or Oracle, or AWS, right? They have data centers. They have huge devices, service providers. So they definitely ask you trace route at packet level. You should know it. Now see what exactly it is. Okay. Once you initiate a trace route. So before going to trace route function, I would like to tell you about TTL value. What do you mean by TTL? Time to leave. Okay. So can anyone tell me where this TTL field will be existed? Which header it is there? Is it Ethernet header,
Oh,
IP? What is that?
IP header.
Yeah,
IP header.
IP header, right? The TTL value will be in which header? IP header.
IP header.
So what it will do? It will avoid the loops in IP routing domain. Okay. The biggest problem in networking is loops. Routing technologies or switching technologies. The biggest problems is loops. In each and every stage, we need to avoid the loops. So in IP, right here, we need to avoid the loops. How exactly the TTL value will avoid the loops? See here. So generally, these are topology, right? So now, if you take one more router here, just understand. I'm just taking one more router here. Okay, this is connected here as well. So R1 is connected to R5, R5 is connected to R3, and R3 is connected to here. Just understand this. Okay, here like this. Okay. Now, so it is in ring format, right? Just understand this. So if you send any packet, right? What do you mean by loop? Suppose if you enter in Hyderabad ring road, right? So if you don't know exit, you will drive in loop format, right? Wherever you started, you will be you will be there, you will reach there only, right? Loop in the sense whatever I'm sending, right? It is coming back to me. That is called loop. So here the packet is sending to R5, R5 is sending to R3, R3 is sending to R2, R2 is sending to R1. So whatever the packet, this is R1 packets. So how loops occur, that is different story. How loops trigger, that is different story that you will learn in routing technologies. But in case if the loop occurs, how exactly it occurs in layer 3? See, R1 is sending a packet to R5. What R5 will do? Same packet will send to R3. Same packet, this is also sent to R2, it is also sent to R1. It means whatever I am sending, right, it is coming back to R1. It's called loop. It's called loop. If the loop is created, right, what will happen? So whatever, if anyone say hi, I need to respond, right? So you are the all candidates, you are asking doubts to me. I can now currently 70 members are in online. Okay. If anyone asks like 5 to 10 members, I'm able to answer. If all 70 members is asking me, right, how can I respond? My CPU will go high, right? Similarly, whatever the packets, right, R1 receiving it, it should process it. It should respond it. So whatever the packets R1 receiving it, right, it should respond it. It should respond and send it back. So if it loop is created, for every packet it responds and the R1 CPU will go high, the interface utilization also will go high. After some time, the R1 router will go down. If router will go down, entire the services will go down, right? So it happened in layer 3. Okay. So now, if you want to stop that, what should we do? There is a TTL value. For IP header, there is a value called TTL. Generally, for layer 3 protocol, if you configure, the TTL value will be 64, or else the TTL value will varies up to 251 to 255. Depends on the protocol, depends on the usage. Okay. So suppose maximum TTL value is 255. Let's take TTL value 255. Now understand things. So, okay. Now R1 is sending a packet to R5 with TTL value 255. Okay. Now R5 is sending it to packet to R3. But you know what? How exactly TTL avoid the loops? when R1 is sending a packet to R5, right? What it will do? It will reduce the TTL value by -1. Okay. Now 255 minus 1, how much? 254. When the packet arrives here, right, R5, what is the TTL value now? 254. Similarly, when R5 to R3, it will go right. Now it will reduce the TTL value of -1. Ante, it means 254 minus 1. How much it is? 253. Like that, it will go R2. So R2, what is the TTL value at R2? 253 minus 1. It is 252. Now it will go here. So that it in case in loop happened, right? It is keep on doing, packet processing here like this. Now at the last, TTL value becomes 0, right? At last, after 255 packet processings, the TTL value will become 0. If the TTL value becomes 0, what will happen? This IP packet cannot be processed further. This IP packet is dead. If the TTL value is 0, it means the IP packet is dead. It cannot process further. Everyone understood? Are you guys understood?
Yes, sir.
So,
Yes, sir.
Yes, sir.
so if the TTL value is 0, the TTL value is 0, it means the packet is dead. So that's why, you know, that's how you can avoid the loops. It means you can, if the loop is happen, it will circulate here up to 255 times only. After that, the packet will be dropped. If there is no packet, there is no process, and your router will be safe, and everything will be work as expected. Understood, everyone? So this is about TTL value. Now, why TTL value come here? Yeah, TraceRoute uses it. Okay. Now let's discuss it. Okay. Let's discuss our normal topology here, and I'm going to remove this. Okay. Yeah. Now I initiated what I have initiated here. I have initiated TraceRoute right here. See, I have initiated a TraceRoute where on R1. Okay. Once you initiate a TraceRoute, what exactly it will happen? R1 sends 3 UDP packets to the destination. Okay. R1 sends 3 UDP packets. Okay. So UDP packets are very aggressive, right? Why it is sending 3 UDP packets? If any packet is missed, right, it will get response with another packet. So remember one thing, wherever you initiated a trace route, right, on that router, it will send a 3 UDP packets with TTL value equal to 1. Why TTL value equal to 1? There is a logic. I'll tell you. Okay. So now, so when you initiate a trace route on R1, R1 sends the 3 UDP packets with TTL value of 1. Okay. And destination is 4.4.4 to the destination 4.4.4. We have a route in our routing table, right? 4.4.4. So we have a route. It means we can go. The packet will exit through G1/0. Okay. So now the packet will go from R1 to R2. Okay. And when it go there, right? What is the TTL value at R2? It becomes 0. Right. Now the packet became R2, right? It came 0. Now R2, what it will do? Now it will generate a error. Okay. So let's discuss this one more time. So when you initiate a trace route for destination 4.4.4, R1 will send a 3 UDP packets with TTL value of 1. So UDP packet with TTL value equal to 1. Now the packet arrives here. So the destination IP address is what? 4.4.4. So packet arrives here on R2, it will check routing table. So what it will check? What is the destination 4.4.4? Do I have route in my routing table? Yes, 4.4.4 route is there in your routing table. However, to process further, your TTL value became 0 now. So I cannot process further. So R2, what it will do? It will generate a error. What error it will generate?
ICMP.
ICMP, ICMP type Type 11 code, yeah.
0.
So type 11 code 0. So this is ICMP error. Type 11 code 0 means TTL is exceeded in transit. This is it. If TTL is exceeded means packet is lost. So R2 will generate this ICMP code. Important. Please remember this important thing they will ask you in interview. Type 11 code 0. Okay. ICMP type 11 code 0. So who will generate this? Who will generate this ICMP type 11 code 0?
R2.
R2, right? Very good. R2. So now generate ICMP. What is the IP header? Source IP. What is the source IP in IP header? 192.168.
$12.2.
Very good. 12.2. What is the destination IP? Where exactly it came?
12.1.
12.1. Yeah.
12.1.
Now, now this error code will go to R1. Now R1 it receives it. Now it will display. What it will display now? It will display the first hop. Okay, first hop 192.168.12.2. It is telling that TTL is exceeded. So how exactly it is learning the next hops? By ICMP error code, by ICMP error packet. So who is generating 12.2, right? Okay, 12.2 is generating ICMP error packet saying that TTL is exceeded. Okay, that's how it learns the first hop. That's how it is displaying here. That's how it is displaying here. Okay, understood? That's how it is displaying. How exactly it is displaying? It is displaying because of this error code. Now, what R1 will do? Okay, TTL is exceeded, right? Now, R2, R1, what it will do? It will generate a UDP packets now with TTL value of what? It will increase TTL value of 2.
2.
So now packet will come here, R2. It will check the destination IP 4.4.4. To reach 4.4.4, you need to go R3. So when it comes R3, right? So here TTL value became 1. When it go to R3, so now TTL value became 0. So now here TTL value became 0, right? It doesn't know how. So packet will lose. So now what will do? R3 will generate again type 11 code 0 saying that TTL is exceeded in transit. And who is generating here? 23. Who is the source address here? 23.3. And the destination is 12.1. Now it came here. Now it will display the next hop of what? 192.168.23.3. Very good. Now TTL is exceeded. Now what will happen? Again R1 will generate UDP packets with TTL value of 3. This time is 3. Okay. Now packet arrives on R2. It will check. It will reduce TTL value of 2 now here. Now from R2 to R3 it will go. It will reduce TTL value of what? 1 here. Now the packet will go to R4. R4 it will go again, it will be 0. Now the thing is, what is the destination IP? 4.4. Right? So on R4 it receives the packet, show IP route, check it. So show IP route. So it will check the destination IP address is 4.4.4. This 4.4.4 is a local route. Yeah, this is my route. Okay, it is reached now. So where exactly 4.4.4 is there? On R4 only, right? So the packet is arrived on R4. Now you no need to process the packet further. So destination is already reached. IP is already reached. Yes or no? IP is already reached. So what happened? IP is already reached. Now you no need any further process. You no need to further. You no need to process this packet further. It means you no need to send this packet further, right? So it's already reached. IP layer 3 is already reachable now. Okay. Now what it will do? IP is reachable, right? Now, after IP address, what layer you will see? Transport layer, right? So transport layer, so what protocol it is using in transport layer? UDP. Okay. So in UDP, so now you may have questions. What is the source port and destination port? So it uses random ports. Okay. There is a range here for especially for trace route. If you see, right, there is a PPT in our, um in our website. Download that. So I will open here. Let me show you. 1 second. Where is the trace route? TCP is here. Yeah, here. See, step by step process is there. You just go to the PPT and learn it. See, same thing, step by step process. Okay. So generally, so what ports it use? Reserved ports. For trace route, there is a reserved ports. 33,434 to 33,523. Okay. What are the reserved ports for trace route? 33,434 to 33,523. Okay, these are the reserved ports. Okay, May 8th batch you don't know maybe because you haven't gone through the headers, right? So don't worry, I'll explain it again. For other people, right? If you understood well, then it's okay. Okay, if you even though you don't understood, don't worry, I'll be here. Okay, so what is the reserved ports? 33,434 to 33,523. Okay, now now here layer 3 is reachable, right? Layer 3 reachable. Now what it should do? It will generate a error. What error it will generate? It's not an error, it is an indication. It will generate a ICMP error code, but it's not a error code, it's an indication. What it is saying? Type 3 code 3 saying that port unreachable, destination unreachable. It means layer 3 unreachable, right? Layer 3 is done. Now what is next? Next is layer 4. What is the destination port? It will be something random. 33,523 something destination port you can say. Okay, destination port. So this port, it's not a service, right? It's a random port. What we need to do, we need to check the layer 3 reachability. That's it. So now what it will check after layer 3 reachability, it will check the layer 4 in case if anything happened. Layer 3 after layer 3, right? You will check layer 4. Now layer 4 destination port is there is no such a port, such a service. So it will generate a ICMP code type 3 code 3 stating that port unreachable, destination unreachable. Okay, what is saying that port unreachable and destination unreachable. Okay, yeah. So once you see this, right, R4 will generate this and it will send to R1. Once you see this, R1 thinks that okay, layer 3 is reachable. I'm not worried about layer 4. Layer 3 reachable successfully. See here, once it is see this, layer 3 is reachable and it will stop doing trace route. It is not tracing now because it's reachable, right? It is not tracing. Okay, yeah. Now whatever I discussed, right, let me explain practically with packet capture here. Okay, so this is a Wireshark analysis. Okay, let's do this. So everyone understood theoretically? Anyone having any questions? Trace route, everyone understood theoretically? Hello.
Yes, sir, clear.
Okay,
Yes, sir.
okay. So now see here carefully, please
Ramesh sir,
observe. Yeah,
that every hop latency is round trip latency, right?
round trip latency, yes, you can say.
Okay.
Yeah, yeah, I'm showing
Ah,
now. Yeah, సో ఇక్కడ
okay.
మనకి you can see త్రీ latencies కనిపిస్తున్నాయి. ఎందుకు? For త్రీ UDP packets. We are sending త్రీ UDP packets, right? That's what is showing త్రీ
Right.
latencies. Okay na? Now see
Round
carefully
trip
observe
latency from each hop.
from each op. Yeah, that's
Right.
correct.
Right.
Yeah.
Correct.
So now see carefully observe what I'm doing now. Trace route 4.4.4. You see some black and red combination, right? What is that? Can we check it one by one? So what is our theory? First, it will send three UDP packets, right? So red color wala. So 427. Let me stop the transaction. 427 721 590. See, this is first UDP packet. This is second UDP packet. This is third UDP packet. First, it will send three UDP packets with detail value 1. So this is a packet capture. Okay. Now if you see right, layer 3. What is the detail value in layer 3? 1. I said right, it will send a UDP packets with detail value of 1. Right? Now it is detail value of 1. And what is the protocol number of UDP? It is 17. Please remember. So the routers cannot understand UDP. I can give Balakrishna as a protocol also. Router cannot understand. I can give Chiranjeevi also, Amitabh Bachchan also. Router cannot understand. Each and every protocol have a protocol number. Based on the protocol number, it understand. Okay, this is a UDP. Now the protocol number is 17. It means it's a UDP protocol. Next layer protocol is UDP. Okay. Now UDP, if you see, right, what is the source port? 491 random, right? As I said, right, 33,434 to 33,523 something is there. So it will choose random actually. Okay. So this is it. It sends a UDP packets. See, this is second UDP packet with the TTL value 1. See, it's TTL value 1. And this is a third UDP packet with the TTL value 1. Okay. Yeah. Now, okay. Now I'm just checking this time is it capturing the video or not. It's capturing. Okay. Now see for first packet it sent, right. So 12.2 is responding. Hey, TTL value is expired. See, TTL value became 0. Okay. So actually at R2 TTL value became 0. It is a response message. It's a response message to R1. Okay. The source. What it is saying? TTL value 1. And you can see here type 11 code 0. Yes or no? What is this? 12.2 is responding with error message, ICMP error message, Internet Control Message Protocol. What error message is? It is type 11 code 0. Type 11 TTL is exceeded in transit. 0 means in transit. Understood? Who is generating? 12.2 is generating. And it is sent to 12.1. Now that's how this 12.2 is displaying here. Okay. 12.2 is a source. It is sending to 12.1. R1 is a 12.1 router, right? So now it is displaying here. Okay. Yeah. Now next time what it will do? This is a 1. So it will send you 3 UDP packets with detail value of 2. Are you seeing it or not? 2. Are you seeing it? It is generating with detail value of 2. Even detail value of 2 also you are getting ICMP error code message stating that detail value is exceeded in transit. Now the third time means this is a 1. This time it is increasing TTL value of 3. This time it is already reached. The layer 3 is reached this time. And you can see ICMP error code type 3 code 3. Are you seeing it? Once layer 3 is reached, right, it will generate a type 3 code 3 saying that destination port layer 4 port is unreachable and destination unreachable. Okay, just port is unreachable, the destination port is also unreachable. Okay, type 3 core 3 is telling that. So this packet will go to the source device. It is once it is received it can understand, okay, layer 3 is reachable and the port is not reachable. Port is doesn't matter for it. The trace route is only for layer 3 and it stopped doing trace route. So now by using trace route it will identify a paths. How exactly it will identify a paths? Same thing. Okay. So how exact? By sending 3 UDP packets. Now in Windows machine we have a mechanism called traceroute. Okay, what is that? Traceroute. Traceroute means it's the same thing. It's the same thing. Traceroute means it's the same thing. Whatever we use, right, traceroute also same thing, but we use in Windows machine. Traceroute is a Linux command. Traceroute is a Windows command. That's it, guys. But the only difference is traceroute uses UDP packets, right? But this traceroute uses ICMP packets, ICMP echo request. But reply you will get ICMP error codes only, but sending packets, right? It will send a request, ICMP echo request. So let me show you here. So now let's do Google traceroute. So now let's come here. Initially we did Google IP address. We try to ping the Google, right? We got the Google IP address. Now traceroute. Give a traceroute command. See, it will identify a path. So what is the first router I can see? My Wi-Fi router. My Wi-Fi router is 1.1. See, my Wi-Fi router address is 1.1. After that, this is something Hathway. I have taken an internet connection from Hathway. See, this is a Hathway router and this is a Hathway another router. See, let's see how many. So Google data center is located somewhere else, right? Let's see how many routers in between them. So maximum up to 30 routers it will show you. How many it will show you maximum? 30. Okay. So you may see star 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 here. Yes or no? Why? It means some people they don't want to show their router. It's in internet, right? They don't want to display their router host name. So they simply block the UDP ports or ICMP ports. So traceroute and traceroute both are same. Traceroute uses UDP, traceroute uses ICMP. So they may block ICMP echo requests. They may block trace UDP ports. So if they block, right, it will show you star star star. Packet is processing, but they may block it. They don't want to display the information. Okay, that's why you see request timeout. Now you can see, right, 252 and 231. See, now this is a complete trace route, to reach Google. So I would like to know who owns this 43.131, who owns this 55.69. So I want to know. So I cannot type in Google each and everything, right? What I can do now? This time you use ChatGPT. Use ChatGPT. So just to get to know the things, use ChatGPT. For learning purpose, don't use it. It will give you wrong information also. Okay. So now what I'm doing, I'm copy. So 80% I use ChatGPT for each and everything. It give you lot of clues. Okay. So now I post the output, right? I'm giving a prompt. What prompt I'm giving? I want to, so simple, breakout breakout the above output, and please tell the please tell who owns the next hop IP sin above traceroute output. So let's see. So it is analyzing. I would like to know who owns this IP address. It is breaking down each and everything. See, now it is breaking down, right? It is clearly telling 1.1 is your home router. Yes, it's correct. It's my private IP address. So this 27 dot, who owns it? My ISP, Hathway. And this is also Hathway only. Hathway Communication ISP only. Now this also Hathway, knock peering router. Okay. So now it is filtered. Possibility, I told you, right? It may be filtered, it may be blocked. Blocked means the port is blocked. That's it. The communication is allowed. Now it is going via Google. See, it's a Google AS. Directly it is pairing with Google backbone. And now Google. So this is what it is. So these all are so finally you will see Google server. So the packet is leaving Hathway, ISP, peer ISP, and then in between there are multiple ISPs also. It is not showing. Finally it is showing Google one. So Google one, Google also lot of ISPs. Google backbone, then it is going to Google, then perfect Google server. Okay. So now this is it. Let's discuss about Tracer Phone Pay. Phone Pay is the Indian thing only, right? Can we check where the Phone Pay server is located? Let's see. I don't know where it is located, but let's see how exactly it is connected. So see, first it will go to my Hathway Wi-Fi router, and then it is going to hathway.com, and see everything it is displaying here. So now it is leaving. This is a Phone Pay IP. Yeah. So like that Amazon. So we got the output. What we got? We got the output. Can we do that? Same way. Please explain with ownership of those next hops. Let's see. Same thing. Okay. Till here it is same thing, right? Now it is going via Google LSC. Oh, no, no, no. So same way. Okay. I think I did not copy it properly. Sorry. I have to copy it and paste it. Yeah. Let's see hop by hop trace. Okay. So yeah, see guys, this PhonePe server is located in PhonePe data center. They are using Tata and BSNL internet connection. See, they are using Tata Communications and BSNL peering. Understood? Hathway, from Hathway to it is going via BSNL or Tata ISP, and then it is going to Cloudflare. And where exactly PhonePe server is spinned? This PhonePe server is spinned in Cloudflare. Cloudflare. Okay. This is a Cloudflare ring. This is a company ISP data center. It is PhonePe is so they not PhonePe is not using AWS or Google. Something Cloudflare INC. Okay, this is a company. Okay, so like that, Amazon definitely use their own services. Like that, you can identify it. Okay, this is all about traceroute, guys. Okay, yeah, I try to explain maximum with practical approach. Okay, so they will ask you in interview because all these service providers like BSNL, Tata Communications, or other service providers and data centers, all the data centers are get input connection from Tata only, right? Service providers. So how data centers, where exactly it is located? So you need to trace the path. Okay, by tracing the path, if any packet loss observed, right? If you get star 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 and it is not resolving, so you will identify till here, till please go on mute, guys. Please go on mute. Seshu, can you please go on mute? Hello, Seshu. Thank you. Okay. So now you can see star star star, right? If you see star star star, it may be filter or it may be blocked or it may be reachable. So, array man, again, Seshu, please go on mute. So the thing is, you need to log into this recent router. So how you troubleshoot? What is the last device we are able to reach? This is the last device, right? If it is this, if the device is in your company, right? You can log into this device and check the connection between the next hop. Okay. So I told you, right? Airtel ISP is there. It is spread across the India. Thousands of routers are there. So you don't know how it is connected. So, but the destination IP is not reachable. You don't know, right? You need to trace it and find the router, log in the router, from the router to the neighbor router, check it whether the connection is there or not. That's how you need to. So the thing is, you need to find the right device. Between source and destination, there are thousand devices. On which device exactly it is getting dropped? How you will identify? By using trace route. Okay, you can by using trace route, you can trace the path. You can identify on which router till what is the last router it is reached. From that router you can start doing troubleshooting. It's easy to troubleshoot. Okay, it's a troubleshooting command. And there is a one more command is called MTR, not a garam masala. It is a okay, it is a my trace route. MTR is a my trace route. Okay, so what it will do, it will send both ping and ICMP and ping and trace route. It will do both ping and trace route. Okay. So for that, it is a tool you need to install it. Guys, in experienced candidate who are working at service provider, I'm telling you especially, you know MTR, right? You used to take MTR. You need to, customer will provide MTR. Okay. MTR means ping and trace route. Both the output he will provide. You need to analyze it. So MTR and destination. What is the destination it is? Let's give destination. So MTR is not recognizing because it's a Linux command. You need to install this MTR package if your device should support. Why I'm asking this?
We,
They will
we
ask in
call it
interview.
WinMTR.
What is that?
We call it WinMTR actually.
Yeah, WinMTR. So okay.
Yeah.
So you mean WinMTR is a command? You mean?
No, it's a one application.
Yeah, it's another application. That's what I'm saying. So just understand the MTR. They used in different aspects. So you need to install MTR package in Linux, or you need to do that. So MTR is also they will ask you especially what it does. it will do both ping and trace. So can we check the example of MTR output? Let me do in Google. So let's ask ChatGPT. This guy can provide anything. So provide me the example of MTR output. Okay, my trace route. See, it look like this. So ping response as well as path. So ping response is latency. It will show you. It will show you like this. Okay, and it will show you how many hops in between. So if you want to do individual troubleshooting, you need to ping and you need to do trace out, right? Instead of doing that, do MTR. Okay, so it will show you the hop by hop and the latency also. Okay, understood, guys? So especially ISPs and data centers, they use this. Okay, this can be helpful to a lot during interviews. So in interview, they won't ask you configuration and all. Everything is already established. They will ask you the troubleshooting, how you will troubleshoot the issues. That's it. So servers, lot of application servers are there. Everything is connected to. I show you right during demo class. All servers are connected to the networking equipment. So the server team will engage us. Hey, server team, incident team, application team, they will ask us, hey, what is exactly happening? My server is not reachable. There is a latency. It is slow loading. My server is slow loading very slowly. So you need to check. You need to isolate. Is there any issue at in my path, networking path? Okay. So these ping and this ping and trace router, you have two eyes, right? One eye is your ping, another eye is your trace route. Please remember, if you are a network engineer, right? So the network engineer profession is in your blood, and these two are your ping and trace route. Why I'm telling you is this, that is important. Our heart is equal to BGP protocol. Seriously, I'm just, telling you the importance of the protocol and the services. Okay. So ping and trace route is very important in networking profession, world, because you have to do troubleshooting. So once you join as a network engineer, every day you use this trace route, ping, trace route, ping. Even I have 12 years of experience. I'm doing in a respective position. I'm using everyday trace route. Not only ping, traceroute ping. 90% of the commands I use these two only. If you don't know that a packet level, right? How you can identify, right? So yeah, that's why I call it out here and telling you and showing everything at practical. So I want to teach you ACLs also, but now time is exceeded. Next Sunday I will start ACLs. Okay, one by one. I don't want to lag it. So I hope this boot camp is useful for you guys. Anyone having any questions? If you have any
ఒక జనరల్
questions, yeah, please go ahead.
నార్మల్ అక్కడ యూడిపి అన్నాడు కదా సార్. సార్ మామూలుగా టీసీపీ రాదా సార్? జనరల్ అడుగుతున్నాను.
So no, TCP రాదు. So if you heard about
ఓకే
last
సార్.
class,
ఓకే. అంటే
right?
మామూలుగా
అదే
అంటే
ఇప్పుడు
టీసీపీ యూడిపి కదా సార్?
అదేండి. ఇప్పుడు మనం ఊరికెళ్ళాలంటే మనం బస్ ఎక్కొచ్చు, ట్రైన్ ఎక్కొచ్చు. మన ఇష్టం అది. రైట్? అలాగా
అవును సార్. ఏదైనా
ఒక్కొక్క
మన
ఏ
ఇష్టం.
అదే. ఇట్లా
ఓకే. ఓకే.
ఒక్కొక్క సర్వీస్‌కి ఒక్కొక్కటి రిజర్వ్ చేసి పెట్టారది. ఓకే. నువ్వు అడగొచ్చు. నువ్వు ఎలా అడగాలంటే క్వెషన్,
ఓకే.
అన్న
అంటే
ఎందు
డిఫాల్ట్ లాగా.
డిఫాల్ట్ లాగా. నువ్వు అడగొచ్చు క్వెషన్ ఎలాగంటే, అన్న ఇప్పుడు నువ్వు ఎందుకు యూడీపీ రిజర్వ్ చేశారు? టీసీపీ ఎందుకు రిజర్వ్ చేయకూడదు అని అడగొచ్చు నువ్వు. ఓకే. అది నువ్వే ఆన్సర్
అది
చేయాలి.
నాకు
ఎందుకంటే
అర్థం కాలేదు సార్. ఎట్లా అడగాలి? రైట్ సార్.
అదే. నేను చెప్తున్నాను. నేను కరెక్ట్ చేస్తున్నాను అనమాట. ఇట్లా అడగొచ్చు అని. సో,
ఓకే
ఇప్పుడు
సార్. ఓకే సార్.
ఇప్పుడు టీసీపీ ఉంది గదా! టీసీపీ ఎలా పనిచేస్తుంది?
అవును సార్.
అది తెలియాలి నీకి. హౌ టీసీపీ వర్క్స్? ఫస్ట్ ఇట్ విల్
ఓకే
ఎస్టాబ్లిష్ ఎ
సార్.
కనెక్షన్. ఆ తర్వాతనే పనిచేస్తుంది.
ఎస్ సార్. ఎస్ సార్.
సో, ఇక్కడ మనకు కనెక్షన్‌తో పని లేదు గదా! నాకేం గావాలి? డేటా ఎళ్తుందా లేదా
ఓకే.
గావాలి.
ఓకే.
దట్స్ ఇట్. సో, అందుకే.
ఓకే సార్.
సో,
ఓకే
కనెక్షన్
సార్.
ఎస్టాబ్లిష్ చేసుకొని డేటా పంపియడానికి టీసీపీ యూజ్ చేస్తాం. ఏదైనా తెలియనివి తెలుసుకోవడానికి
ఓకే
యూడీపీ
సార్.
యూజ్ చేస్తాం. అంటే ఒక గూఢచారిలాగా యూజ్
ఓకే
చేస్తాం
సార్.
యూడీపీని. అండర్‌స్టూడ్?
అర్థమైంది సార్.
దట్ ఈస్ ద
ఓకే
డిఫరెన్స్.
సార్. అదే ఎందుకు వచ్చింది అర్థం. ఓకే సార్.
యాహ్!
ఓకే
గుడ్
సార్. ఓకే.
క్వెషన్.
థాంక్ యూ.
గుడ్ క్వెషన్ బ్రదర్. సో, జనరల్లీ యూ
రమేష్
నీడ్ టు
గారు,
యాహ్!
why 3 UDP packets? I mean,
దట్స్ వైట్ నేను స్టార్టింగ్‌లోనే చెప్పా. 3 యూడీపీ ప్యాకెట్స్ అంటే యూడీపీ ఈస్ వెరీ అగ్రెసివ్ అండ్ ఫాస్ట్. సో, ట్రాన్సిట్ అయ్యేటప్పుడు ప్యాకెట్ లాస్ అవ్వచ్చు యూడీపీ ప్యాకెట్. ఓకే. ఒక ప్యాకెట్
oh,
లాస్ అయినా ఇంకో ప్యాకెట్ నుంచి రెస్పాన్స్ వస్తుంది అని. అర్థమైందా?
oh,
అట్లా.
fine. Okay.
యాహ్! ఇంకేమైనా క్వెషన్స్ ఉన్నాయా యూడీపీ గురించి? సో, నాట్ టీసీపీ గురించి? ఐ మీన్ సారీ, ట్రేస్ రూట్ గురించి? యాహ్!
Sir, after like once it goes to R2, it will know that it is not reachable. Then
హ్మ్.
again, when it goes to I mean R1, R2. So how it will know that it has to increment the TTL by 2, 3 like that?
Yeah, by sending this ICMP error message, right? It is sending ICMP error code type 11 code 0, TTL exceeded. The R2, so the packet came here. So UDP packet came here, and the destination IP address is there in routing table. It is there in your routing table. However, if you want to process further, the TTL value is 0, right? So R2 is generating type 11 code 0 error and sending to R1. Now R1 thinks that okay, R2 has a reachability, but TTL value became 0. So R1 will learn the next hop address, R2 address, and display here, and it will start sending UDP packet with TTL value 2, and it will send it again. Like that. How many routers in between, right? Till the destination reach, right? It will keep on increasing step by step TTL value. Understood?
Okay, so based on if next whatever routing table information is there, it will see the reachability and then increase the TTL value.
No, 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 no. You have to understand the process. First, the packet arrives here. Okay.
Hmm.
So before UDP packet, what is the packet ma? IP, right? So
Huh.
what is the destination IP? 4.4.4. Yes or no?
Hmm. Yeah.
First, what lookup it will do? UDP lookup or packet lookup?
First packet.
Packet lookup. So
Hmm.
packet lookup routing table లో ఇది చెక్ చేస్తుంది whether
Hmm.
I have a route or not. Yeah, you have a route. Then it will go to the next header lookup. సో ఈ నెక్స్ట్ హెడర్ లుకప్ పోయే ముందరనే ప్యాకెట్ హెడర్ లోనే టీటీఎల్ వాల్యూ 0 ఉంది నీకు. సో టీటీఎల్
Hmm.
వాల్యూ ఎక్కడ ఉంటుంది? ఐపీ హెడర్ లోనే కదా.
Hmm.
ఓకే.
No,
సో I have a route. I have a route in my routing table. Okay. However, the TTL value became 0 here. So what R2 will do? It will generate a type 11 code 0 ICMP error code. Okay. That code means TTL is exceeded. It is precisely telling that TTL is exceeded. Okay. What is that? Type 11 code 0 here. 1 second. Here it is.
Hmm.
I already draw it, right? I explained it already.
Yeah.
Okay. So type 11 code 0, it is telling that TTL is exceeded. Okay. And it will go to R1. R1 receives it, and it will learn the source address 12.2 and display here. And based on this understanding, right? So TTL is exceeded, right? It will increase the UDP value, UDP TTL value, I mean the packet value to TTL value to, and send it out. Okay. So it will initially it sent with 1, right?
Hmm.
Initially it sent with 1. Now it will increase to 1 plus 1. 1 by 1 it will increase. Okay. Now it will go here. After that it will be reduced to 1, and then it will go to R3. R3 here it will reduce to 0. Now R3 again will generate a error code and send to source. Source will again increase the TTL value to 3. Like that it will go. Understood now?
Yes, sir.
Yeah.
Yeah.
Yeah. Okay. So that's all for today, and I'm stopping the recording now. Thank you so
Sir.
much.